In this section, we're going to talk about physical and chemical properties and how they can be used to identify and separate different substances.
Physical properties of matter are things that can be observed without changing the substance into something else. So we can change a solid or liquid or gas, or simply just measure if it's solid, liquid, or gas, and that's not going to influence the type of chemical compound. We can measure its size, its shape, its volume, its density. That doesn't change what the matter looks like. We can see if it's powdery or durable, and that's not going to change the substance. We can rip it, tear it, break it, bend it. Those are all things that we can measure without changing what that substance is. On the other hand, chemical properties describe chemical reactions. So we can only observe this thing during a chemical reaction in which it's changed to something else. So, we can only tell if something is flammable by seeing if it burns. And of course, if it burns, it's no longer the same compound at the end. We can only see if something rusts by changing it into that new form of rust. These physical and chemical properties help us distinguish one type of matter from another. When we say something is a pure substance, we're essentially saying it cannot be separated. All material has the same chemical structure. So in this case, in blocks B and C, all the chemicals in B are the same. We physically cannot separate them. Same thing with all the molecules in C are the same. We physically cannot separate them. Now, we could tear these molecules apart to separate the purple and the green atoms, but that would be a chemical reaction. So when we look at mixtures, like this mixture in box D, this is a material that can be separated by physical properties. Each one of these molecules or atoms will have a physical property related to its shape. And since we have many different shapes, each of these things can be separated in different ways. Now, what's important to remember about a chemistry class that's unique about the real world is that almost everything we have will be pure or relatively pure. So we'll have a pure substance here. That almost never exists in the real world. The real world is almost entirely made up of mixtures. But we can talk about ways to separate those mixtures. For example, one way is distillation. And you've probably seen this before somewhere. Again, the two different pieces of matter we have in salt water is salt and water. And so water is boilable, salt is not. Salt does not melt or boil very easily. So what we can do is we can heat up that salt water, causing the water to boil. The salt cannot boil and stays behind. At that point, we cool this steam down, and that allows the water to cool back into a liquid and then pour out the other side. So we end up with pure water, and the salt stays behind. We can also separate out different inks by their solubility in solution. So here we have what looks like a single chemical compound, ink, but when you let a organic solution run up this piece of paper, the different types of ink actually run into the solvent at different speeds, and so you can actually see all the different inks that are involved in that pen. So this is really an extremely busy slide, so I apologize here. But what we're going to say is that all matter essentially breaks down into four major groups. If something is a pure substance, it contains only one type of compound or only one type of particle. In that case, what we have is either an element which contains one type of atom or a compound which contains more than one type of atom. On the other hand, if it contains more than one type of molecule, it is a mixture. And that settles us either to heterogeneous mixtures, which means that it's essentially, heterogeneous means different phase. And so we're looking at something that has more than one phase. So example, the ocean water rolling up against the beach means we have a solid phase and a liquid phase here. On the other hand, if something is uniform throughout, or you really can't tell the difference between different groups, like this cup of tea looks the same throughout. We don't have any obvious solids in this tea as written. We'd say that's homogeneous, or it's often said as homogeneous. Literally, homogeneous means same phase, and so these are all part of the liquid phase. Now, it's a little tricky to analyze these, but, I try to go with very concrete, specific examples here. So take a second and figure out which category each of these would fit into. I'll give you a 5-second pause, and I'll walk through them. Okay. So, iron metal. Again, if you don't have a periodic table in front of you, I suggest downloading it. We're going to start using it here really quickly. But iron metal is element number 26. It's by the element Fe, which is a little confusing. If you don't know your periodic table yet, that's a toughie. But because it's made up of only one element, this is a pure substance and element. Sugar water is made up of sugar and water. They are two different substances, and so this is a mixture. And if you dissolve sugar in water, generally what you have is a homogeneous or homogeneous mixture. The sugar dissolves into the water, and it all looks like one solution, right? You can't tell the difference placing sugar water next to water, which is which. Now, it is possible to add so much sugar to water that it doesn't dissolve anymore. If you think about sweet tea, and there are people out there who add sugar to sweet tea, eventually it gets to a point where it just can't dissolve. At that point, you could argue it's a heterogeneous mixture. But generally, I'm trying to go with the simplest possible image here. Air. Air is not a pure substance. It's made up of hydrogen, nitrogen, oxygen, carbon dioxide, carbon monoxide, H2O, a bunch of other gases. So it contains many, many substances, so it's a mixture. And because you can't look at it and see that difference, we're going to say homogeneous. Chicken noodle soup, chickens, noodles, separate chemical substances. In fact, meat is really a mess as far as chemistry is concerned. We'd say chicken in general, or meat in general, is lots of chemicals involved, because it isn't just one chemical in meat, but thousands of chemicals, not just not just pesticides or anything like that, but just inside of a cell of any living thing, there are thousands of chemicals necessary to keep something alive. Okay, but getting away from that, in chicken noodle soup, there is clearly a liquid and a solid that's more than one phase, heterogeneous mixture. Okay, hydrogen gas. Again, we haven't got to the periodic table yet, so if you haven't seen the periodic table before, this is going to seem weird. But hydrogen is the first element on the periodic table. Since hydrogen gas contains only one element, it must be a pure substance and an element. Okay. Coffee. Again, coffee is made up of something in water coloring it brown. Okay, so even though we can't describe exactly what it is, by definition, it must be a mixture. And again, I'm going to say homogeneous because it's all going to be in the liquid. Now, if you want to argue there's grounds in your coffee, okay, you could say it's heterogeneous. But generally speaking, I'm looking for the simplest possible picture. Okay, water. Water's tricky. When I say water in this class, I'm always talking about distilled, pure water. Okay, I always mean, water, single, pure chemical compound, H2O. Okay, now, if you get tap water, that's a mixture, which is why, in the lab, you should generally never use tap water unless specifically asked for it. Because tap water contains a bunch of things. Some of them are good. Some of them keep your water clean. They keep it bacteria-free. Fluoride is good for your teeth. All those things. But there are also things in it that are bad. Metal ions, for example. Some of them are good, by the way. Some of them are not. Copper ions, for example, lead ions are probably in your water to some limited extent. Just because you can't really purify this stuff completely unless you have a water filter on your device. So, again, when you talk about water in this class, we are going to say pure substance, chemical compound. NaCl, pure table salt, is a chemical compound as well. And again, in Chapter 2, we're actually going to talk about some compounds. But anytime we have two element symbols side to side like that, that says we have a specific chemical formula. Ice water. Again, I'm going to assume deionized water. These are all different phases of the same element. So we're still going to say pure substance, chemical compound. All right, well, that's the end of Chapter 1. I'm going to experiment with something different for Chapter 2. But I'm out of time today, so hopefully I will have this up later. But that gives you something to work on for the first week of assignments. Send me an email if you have any questions.